সো আজকে আমি সাইক্লিক গ্রুপের উপর টোটাল 25 এমসিকিউ প্রবলেম ডিসকাস করব। সো প্রিভিয়াস লেকচারে আমি সাবগ্রুপের উপর 20 প্রবলেম ডিসকাস করেছিলাম, রাইট? সো আপ টু 65 প্রবলেম অলরেডি আমি সলভ করে দিয়েছি। সো দিস ইজ কোশ্চেন নাম্বার 66. We know what is cyclic group. What is cyclic group? Let G be a group. G is said to be cyclic group if it has a generator, that is every element, that is if G can be expressed in the form, if G can be expressed in the form G is equal to a to the power n, where n is an integer, and this is a is called the generator of the cyclic group, right? We know the definition of cyclic group. Let G be a group. G is said to be cyclic group if G can be expressed in the form G is equal to a to the power n, where n is an integer. That means every element of G is an integral power of a, and such a is called the generator, and it is denoted by this. Okay, a is called the generator of the cyclic group, right? Z comma plus is a cyclic group. What are the generators? 1 and -1. These are the generators. It should be noted that if A is a generator of the cyclic group, then A inverse is also a generator of the cyclic group, right? So 1 is a generator of the cyclic group. So 1 inverse, that is -1, with respect to addition. With respect to addition, inverse of, with respect to addition, inverse of 1 is -1, right? With respect to addition, inverse of 1 is -1, right? What is the identity element? Identity is 0, so 1 inverse ki -1. So Z comma plus inverse 1 inverse ki -1. So what are the generators of the cyclic group Z comma plus? 1 and -1. Okay, ঠিক। So we know these are the examples already discuss করে দিয়েছি আমি, ঠিক আছে? So these are the properties of cyclic groups. So আমি যখন MCQ প্রবলেমগুলো ডিসকাস করব, যে যে প্রপার্টিস গুলো আমার রিকোয়ার্ড থাকবে সেগুলো আমি ডিসকাস করে দেবো, ঠিক আছে? ওকে, সো এই টোটাল যে প্রপার্টিস গুলো বলেছি, এই প্রপার্টিস গুলো খুব ভালো করে প্র্যাকটিস করতে হবে, ঠিক আছে? এই প্রপার্টিস গুলো ভালো করে একদম পুরো পয়েন্ট করে মাথায় রাখতে হবে, নাহলে কিন্তু পারবে না, ঠিক আছে? Every cyclic group is abelian, but converse is not true. That means a cyclic group must be abelian. Cyclic implies abelian. Okay, সো আমরা বেসিক্যালি এই প্রপার্টিসের উপর বেস করে আমি এমসিকিউ প্রবলেমগুলো ডিসকাস করব। সো লেট আস স্টার্ট ফার্স্ট প্রবলেম। হুইচ অফ দি ফলোইং গ্রুপ ইজ এ সাইক্লিক গ্রুপ? সাইক্লিক গ্রুপ মিন্স ইট হ্যাজ এ জেনারেটর, রাইট? A group G is said to be cyclic if it has a generator. So real set of real numbers with respect to addition, it has no generator, right? So Z comma plus, it has generator 1 and -1. So Z comma plus, this is a cyclic group. Okay, R comma plus, this is a group, but that are not cyclic group because it has no generators. Okay, it should be noted that Z is an infinite cyclic group with two generators, 1 and -1. Z comma plus, this is an infinite cyclic group whose generators are 1 and -1. যে কোনো সাইক্লিক গ্রুপের দুটো জেনারেটর, হচ্ছে A, এটা হচ্ছে A ইনভার্স, ঠিক আছে? So next question, the number of generators in an infinite cyclic group. The number of generators in an infinite cyclic group is 2. For example, if you consider the group Z comma plus, just you consider this group Z comma plus. So this is a cyclic group, right? Basically this is an infinite cyclic group. This is an infinite cyclic group, right? So what are the generators of this cyclic group? The generators of this cyclic group are 1 and -1. Okay, so if G, that means an infinite cyclic group has two generators, which are A, that is if A is an element, if A is a generator of the cyclic group, then A inverse is also a generator of the cyclic group. Here A1 is the generator of the cyclic group, 1 inverse, that is -A, so that is also a generator of the cyclic group. এরকম কোনো ব্যাপার নেই যে একটা গ্রুপ যদি ইনফাইনাইট সাইক্লিক গ্রুপ হয় তাহলে ওর ইনফাইনাইট জেনারেটর থাকবে, দ্যাট ইজ নট ট্রু, রাইট? ফর এক্সাম্পল Z comma plus, this is an infinite cyclic group, but it has two generators that are 1 and -1. So the number of generators of an infinite cyclic group is 2. Okay, clear? So the number of generators of a cyclic group Z4 comma plus. This is a very, very important example. The number of generators of a cyclic group Z4 comma plus. It should be noted that Zn comma plus, that is a cyclic group. Zn comma plus. So this is a cyclic group. Now, how to find the generator of this cyclic group? So number of generators of Zn comma plus. So this will be Euler's phi function. That is what is Euler's phi function? That is the number of positive integers less than n and prime to n. Number of positive integers less than n and prime to n. Euler phi function, that is denoted by, defined as phi 1 is 1. Getting my point? Phi 1 is 1 and phi n. So this is defined as the number of positive integers less than n and prime to n. Okay. So for this problem, we have to find the number of generators of Z4 comma plus. Number of generators of Z4 comma plus, that is phi 4. How to calculate? Just note this result. These are the very important results. Phi p is p minus 1, where p is prime. Okay. Phi mn, phi p to the power k, that is p to the power k minus p to the power k minus 1. Or this can be also written in the form just k common, so 1 minus 1 by p. Okay. So phi p is p minus 1. What is p? P is prime basically. What is p? P is prime. Next one is phi mn, where m and n are relatively prime. So this will be phi m into phi n. এই তিনটে রেজাল্টের উপর বেস করে আমি Euler's phi ফাংশনগুলো ইজিলি ক্যালকুলেট করতে পারবো। ঠিক আছে, we calculate Euler's phi function by these three formula. Okay, so phi 4, so this can be written as phi 2 square. P is prime, just apply this result. Phi p to the power k is p to the power k minus p to the power k minus 1. So p to the power k minus p to the power k minus 1. 2 to 2 square, that is 4, minus 2, that is 2. Okay, so which option is correct? So option A is the correct answer. So the number of generators of the cyclic group Z4 comma plus, that is 2. Okay, so option A is the correct answer. So what is Euler's phi function? That is Euler's phi function is defined as phi 1 is 1 and phi n, that is number of positive integers less than n and prime to n. Okay, this is the process to find the number of generators of the cyclic group Zn. It is a very, very important example. Okay, so let G be a group of order 49. It should be note if order of G is p square, note this point, if order of G is p square, if order of G is p square, where p is prime, then G must be abelian but not cyclic. G is abelian. Note this point. If order of G is of the form p square, okay, where p is prime, then G must be abelian. So here we see that G be a group of order 49. So what is given here? Order of G is 49. That means 7 square. So which is of the form p square. So this implies that G is abelian. So option A is the correct answer. Okay. Next problem. Every group of order 4 is cyclic, non-abelian, abelian, none of this. Just see, every group of order 4. What is, suppose G is a group, just recall this result. If order of G is p square, where p is prime, then G is abelian, right? Every group of order 4, suppose G is a group of order 4, that is order of G is 4, that is 2 square, that is this is of the form p square, that means G is abelian. Okay, so but not cyclic, so option C is the correct answer. It should be noted that cyclic implies abelian, but abelian is not necessarily implies that it is cyclic. Okay, if order of G is p squared, then G is abelian but not cyclic. Okay, therefore it is very important. Of order 4 এর কি কি গ্রুপ হতে পারে? Kleins 4 group, it is order 4. Z4, that is also order 4. ঠিক, Kleins 4 group, this is, we know that this is non-cyclic. Kleins 4 group, this is non-cyclic, but Zn is cyclic, so this is cyclic. ঠিক, Kleins 4 group is abelian, right? Kleins 4 group is abelian. Kleins 4 group is abelian, but it is not cyclic. Z4 is cyclic, so cyclic implies abelian, so this is abelian also. So what we can say, every group of order 4 must be abelian. Getting my point? এই প্রবলেমটা এভাবে সলভ করতে পারো। every group of order 4, চার অর্ডারের গ্রুপগুলো কি? Z4, Kleins 4 group, these are the groups of order 4. Kleins 4 group is a abelian group, but it is not cyclic. Z4 is a cyclic group. We know that every cyclic group is abelian, so Z4 must be abelian group. Okay, so K4, Kleins 4 group, this is abelian, as Kleins 4 group is abelian, Z4 is also abelian, so every group of order 4 is abelian. You can solve this problem also this way. Okay, so next problem, the number of elements of order 8 in the cyclic group of order 8. The number of elements of order 8 in the cyclic group of order 8. That means we have to calculate the number of generators of this group of order 8. Number of elements of order 8 in the cyclic group of order 8. That means we have to calculate number of generators of the cyclic group of order 8. I mean, generator কি করে calculation করি? This is the result, right? Number of generators, that is Euler's phi function. দেখো phi n, that is Zn এর অর্ডার কি হবে? Order of Zn is 8, that is the number of generators is calculated phi of order of the group. ঠিক, ঠিক আছে, তাহলে এখানে সাইক্লিক গ্রুপটা কি দেওয়া, অর্ডার কি দেওয়া আছে? What is given here? The order of the cyclic group is basically 8, so we have number of elements, that means we have to calculate number of generators, so basically we have to calculate phi 8. That means phi 2 cube. We know that phi p to the power k is p to the power k minus p to the power k minus 1, that is 2 cube minus 2 square, that is 8 minus 4, that is 4. Okay, so which option is correct? So option C is the correct answer. Okay, the number of elements of order 8, that means we have to find the number of generators of the cyclic group of order 8. So now how to find number of generators? That is Euler's phi function, that is phi n. So here the order of the group is 8, so we have to calculate phi 8. Okay, so option C is the correct answer. Next problem, দেখো আমি বলেছিলাম যে আইসোমরফিক কিছু কিছু প্রপার্টিজ গুলো জানতে হবে। জাস্ট ফার্স্ট অফ অল নোট দিস প্রপার্টি, it should be note that Zn is a cyclic group, right? Note this, Zm cross Zn, so this is cyclic, this is cyclic if and only if GCD of M and N is 1. For example, suppose if you consider this, note this point, it is a very important, Zm cross Zn or Zn cross Zn, this is cyclic if N and M are relatively prime. For example, suppose if we consider this group cyclic Z3 cross Z2, can we say this is cyclic? Obviously this is cyclic because GCD of 3 and 2 is 1, so obviously this is a cyclic group. This is cyclic. Why this is cyclic? Because since GCD of 3 and 2 is 1. But if we consider this group, suppose Z3 cross Z9, what is the order of this group? Basically order of the group is Z, what is basically this is Z27. Okay, so order of the group is 27. Can we say this is cyclic? This is not cyclic because 3 and 9 are not relatively prime. Okay, so this is not cyclic, this is not cyclic. Why this is not cyclic? Since GCD of 3 and 9, so this is 3 which is not equal to 1, that is 3 and 9 are not relatively prime. So it is a very, very important result. It is very, very important result that Zn cross Zn, so this is cyclic if and only if M and N are relatively prime. It is very, very important result. Zm cross Zn, that is cyclic if and only if M and N are relatively prime. Next point, just see this. Zm cross Zn or Zn cross Zm. So this is isomorphic to Zmn. This is isomorphic to Zmn. Okay. Just see this problem. The number of generators of the cyclic group this Zp cross Zq, where P and Q are distinct primes. Achha, Zn cross Zn, this is isomorphic to Zmn if M and N are relatively prime. If GCD of M and N is 1. Okay. Zm cross Zn, this is isomorphic to Zmn if GCD of M and N is 1. That means if M and N are relatively prime, then we conclude that Zn cross Zn, this is isomorphic to Zmn. Okay. So here it is given that we have to calculate the number of generators of this cyclic group. Obviously, this is a cyclic group. Why this is cyclic group? Zp cross Zq is a cyclic group. Why this is cyclic group? Zp cross Zq cyclic group. Why? Because here it is given that P and Q are distinct primes. That is, P and Q are relatively prime. Okay. So Zp cross Zq, this is isomorphic to Zpq. What is the order of this group? Order of this group is PQ. Now we know that how to calculate number of generators. That is, the number of generators of a cyclic group is Euler's phi function, right? Just this, it is a very, very important result. It is a very, very important result. The number of generators, just this, the number of generators of a cyclic group G of order n is phi n. The number of generators of a cyclic group G of order n is Euler's phi function, that is phi n. Okay. Suppose G is a cyclic group of order n, then what is the number of generators? That is phi n. What is phi? Phi is the Euler's phi function. Okay. So here we have to calculate. ZPQ, this is a cyclic group. What is the order? Order is PQ. So we have to calculate phi PQ, phi Euler's phi function. P and Q are distinct primes. So we know this property. If M and N are relatively prime, then phi Mn is phi M into phi N, right? So this will be phi P into phi Q. P is a prime number. Also we know that phi P is P minus 1, where P is prime. Let's see this. Phi P is P minus 1 when P is prime, right? So phi P, that is P minus 1, phi Q, that is Q minus 1. So what is the number of generators of this group? The number of generators of the cyclic group Zp cross Zq, that is P minus 1 into Q minus 1. So it is a very, very important result. The number of generators of the cyclic group of order n is phi n. The number of generators of a cyclic group of order n is phi n. What is n? N is the order of the cyclic group. This is a cyclic group because P and Q are distinct primes. That is, P and Q are relatively prime. Okay. So order of this Zp cross Zq, this is isomorphic to Zpq. So order of Zq is PQ, right? So Zpq is a cyclic group of order PQ. So how to calculate number of generators? That is phi PQ. Okay. Same problem. The number of generators of a cyclic group of order P. Here G is a cyclic group of order P. We have to calculate the number of generators. That is phi P. Phi P is P minus 1. Okay. So which option is correct? So option B is the correct answer. Okay. Next problem. The number of generators of a cyclic group of order 2 to the power k. What is given here? Here G is a cyclic group what is given here? G is a cyclic group of order 2 to the power k. We have to calculate the number of generators. Number of generators of a cyclic group G of order n, that is phi n, right? If G is a cyclic group of order n, then the number of generators will be phi n. Here the order of the cyclic group is 2 to the power k. So basically this is n, right? Order of G is 2 to the power k. So phi 2 to the power k. We know this property, that is phi p to the power k. So this will be p to the power k minus p to the power k minus 1, where p is a prime number and k is a positive integer. So 2 to the power k minus 2 to the power k minus 1. So taking 2 to the power k common, so 1 by 1 minus 2, that is 2 to the power k into 1 by 2. So that is 2 to the power k minus 1. So option C is the correct answer. Okay, clear? So next problem. Let n be a positive integer and G be the set of all nth roots of unity. Then the generators of the cyclic group G with respect to multiplication are the roots of the equation x to the power n minus 1 is equal to 0. The special roots of the equation x to the power n minus 1 is equal to 0, infinite, none of this. It should be noted that the set of all nth roots of unity forms a cyclic group with respect to multiplication. This set of all nth roots of unity forms a group with respect to multiplication. Now, what is the definition of special roots? Just see the definition. Suppose this equation is called binomial equation. Basically, the roots of this equation x to the power n minus 1 is equal to 0, which is not a root of this equation x to the power m minus 1 is equal to 0, where m is positive integer less than n, where m is an integer less than n. So this is said to be a special root or primitive root of this equation. So এই রেজাল্টটা দেখো ভালো করে। The special roots of this equation are cos 2k pi by n plus I sin 2k pi by n, where k is the positive integer less than n and prime to n. The special roots of this equation x to the power n minus 1 is equal to 0 are of the form cos 2 pi r by n plus I sin 2 pi r by n, where r is a positive integer which is less than n and prime to n. Okay, তাহলে জেনারেটরের কনসেপ্টটা কি? What is the how to find generator? Basically, the number of generators of a cyclic group is Euler's phi function. Just recall, the number of generators of a cyclic group of order n, that is phi n, right? What is phi n? Phi n is the Euler's phi function. What is Euler's phi function? Euler's phi function is defined by phi 1 is equal to 1 and phi n, this is number of positive integers less than n and prime to n. Just see the definition of Euler's phi function. Phi n, this number of positive integers less than n and prime to n. The phi n is defined by the number of positive integers less than n and prime to n. So this is Euler's phi function. How to calculate number of generators? The number of generators calculated by the formula phi n. Number of generators of a cyclic group, the number of generators of a cyclic group of order n is phi n. Okay, just apply this concept. We have to find the number of generators of a cyclic group. That is, just see, the special roots of this equation are of the form this, where r is a positive integer less than n and prime to n. That means, দেখো concept টা বোঝা গেল? Number of generators, that is number of positive integers less than n prime to n, right? So option B is the correct answer. That is, this is a roots, the special roots of this equation, special roots of this equation x to the power n minus 1 is equal to 0. Okay, so next problem. In a cyclic group of order 10, দেখো 10 order at a cyclic group, for example Z10. Z10 is a cyclic group. We know that Zn is a cyclic group with respect to addition, right? So if you consider this Z10 is a cyclic group of order 10. What are the elements of Z10? The elements of Z10 are 0, 1, 2, like up to 9, right? The number of elements of order 5, মানে 5 অর্ডারের কতগুলো এলিমেন্টস থাকবে? in this group, we already know how to calculate order of an element. আমি অলরেডি ডিসকাস করে দিয়েছি। দেখো এখানে টু এলিমেন্টের অর্ডার কি হবে, 5 অর্ডারের লাগবে, ঠিক আছে। অর্ডার অফ 2 2 প্লাস 2 প্লাস 2 প্লাস 2 4 4 প্লাস 2 6 6 প্লাস 2 8 8 প্লাস 2 10 10 কে 10 দিয়ে ডিভাইড করব, রিমাইন্ডার কি হবে 0। সো বেসিক্যালি দিস ইজ মডুলার সিস্টেম and addition modulated, so order of 2 is 5, ঠিক। Similarly if you can calculate order of 4, দেখো 4 এলিমেন্টের অর্ডার কি হবে, 4 plus 4 8 8 plus 8 তো নিশ্চয়ই 10 দিয়ে ডিভাইড করতে হবে না, 8 plus 4 that is 12 12 কে 10 দিয়ে ডিভাইড করে রিমাইন্ডার 2, আমার টার্গেট কি আইডেন্টিটি এলিমেন্ট পেতে হবে, that is 0 পেতে হবে। 12 plus 4 16 16 কে 10 দিয়ে ডিভাইড করে রিমাইন্ডার 6 হবে না। নেক্সট 20 20 কে 10 দিয়ে ডিভাইড করে রিমাইন্ডার 0, that is order of 4, so that is 5. Similarly order of 6 will be 5, order of 8 will be 5, so we have 4 elements of order 5 in this group. Okay, আমি অলরেডি ডিসকাস করে দিয়েছি কি করে অর্ডার ফাইন্ড আউট করতে হয়, রাইট। What is the definition of order of an element? An element A is said to be order n if n is the least positive integer such that a to the power n is equal to e. This is with respect to multiplication, and with respect to addition n a is equal to e. Okay, already discuss করে দিয়েছি, সো এটা আমি আর ডিসকাস করছি না এখন। ওকে, সো in this group order of 2 is 5, order of 4 is 5. Similarly if we can calculate order of 6, that is also 5, order of 8, that is also 5. So we have 4 elements, 2 4 6 8 that has order 5. Okay, so option A is the correct answer. Okay, clear? So next problem. Basically this is the theorem. Okay, let G be a cyclic group of order n, order of G is n, let G be a cyclic group of order n, and M is a divisor of n. M is a divisor of n, that is M divides n. ठीक, then which of the following is true? That basically this is a theorem. Okay, G must have a unique subgroup of order n. If G is a cyclic group of order n and M divides n, then G must have a unique G must have a unique subgroup of order m. So this is the theorem. If order of, suppose G is a cyclic group of order n and m divides n, then G must have a unique subgroup of order m. Okay, so this is the theorem. So option C is the correct answer. Okay, ঠিক আছে, আমি একটু ফাস্ট বলছি কারণ এখানে অনেকগুলো প্রবলেম ডিসকাস করব। ওকে, ঠিক, জাস্ট কনসেপ্টটা বোঝার চেষ্টা করো, you can solve this. Okay, so next problem. G is generated by A, that means here it is given that G is a cyclic group generated by the element A of order 30. What is given? Order of the group, what is given here? G is a cyclic group generated by the element A and order of G is 30. Okay, we have to calculate G colon this. Just recall this, G colon H, that is order of G divided by order of H. Note this point, just apply this. So here we have to calculate this, or this is called indexer basically. Okay, G, just you consider this H, so order of G divided by order of this, that is order of this element. Okay, now recall this, we know that order of A to the power k, we know this property, order of A to the power k, so this equal to order of A. Suppose order of A is m, then order of A divided by GCD of m, k. Can you remember this result? order of a to the power k, so this is equal to order of a divided by gcd of m comma k. What is m? M is the order of this element. ঠিক আছে? So what is order of this? That means just apply this result. So order of g divided by order of a to the power k, order of a to the power k, that is order of a divided by gcd of m comma k, right? Order of a divided by gcd of m. M is the order of this element. দেখো এখানে G is a cyclic group generated by the element A. What is the order of this cyclic group? Order of this cyclic group is 30. Order of this cyclic group is 30. So order of its generator will be 30. So order of A basically 30. ঠিক? So order of G, it is given that order of G is 30. ঠিক? Generator order কি হবে? 30 divided by GCD of M comma K. দেখো M হচ্ছে তোমার 30 আর K হচ্ছে তোমার 5. ঠিক আছে? So 30 and 5 and 30. Okay, that means 5 and 30 GCD কি হবে? Is 5. So ultimately we get, okay, so which option is correct? So option D is the correct answer. Just apply this concept, order of a to the power k, order of a to the power k. So this will be order of a divided by gcd of m and k. What is m? M is the order of the element A. Here G is a cyclic group generated by this element, so generated by A. What is the order of the group? Order of the group is 30. So generator order ki hobe 30. So order of A will be 30. Okay, ঠিক আছে? So order of A is 30. That means order M is basically 30. Okay, ঠিক? So option D is the correct answer. Next problem. Let G be a cyclic group of order 60. What is given? It is given that G is a cyclic group of order 60. Then the number of subgroups of G এর subgroup কি হবে? How many subgroups of G? Just recall this result. We already know. Just see this result. The number of subgroups of a cyclic group of order n is tau n. What is tau n? That is the number of positive divisors of n. Number of positive divisors of n. Tau function আমরা কি করে ক্যালকুলেট করি? আমি অলরেডি ডিসকাস করেছি, রাইট? The number of subgroups of a cyclic group of order n. Suppose G is a cyclic group of order n. Suppose G is a cyclic group of order n. Then the number of subgroups will be tau n. What is tau n? The number of positive divisors of n. ঠিক আছে? So here basically we have to calculate tau 60. Just see, G is a cyclic group of order 60. Number of subgroups. So number of subgroups. Number of subgroups of G will be tau 60. Tau 60 আমরা কি করে ক্যালকুলেট করব? Just 60 কে প্রাইম ফ্যাক্টরাইজেশন, রাইট? Just 60 কে ফ্যাক্টরাইজেশন করো। That means 2a square. So 60 means 2a square into 3 to the power 1 into 5 to the power. So therefore tau 60, what is the process? পাওয়ারের সঙ্গে জাস্ট 1 অ্যাড করবে, ঠিক আছে? 2 plus 1, পাওয়ারের সঙ্গে কি করবে? 1 অ্যাড করবে, পাওয়ারের সঙ্গে কি করবে? জাস্ট 1 অ্যাড, ঠিক? So 2 plus 1, 3 into 2 into 2, so 12, ঠিক? ঠিক আছে? So tau 60 will be 12. So the number of subgroups of the cyclic group of order 60 will be 12. So we have 12 subgroups. Okay, ঠিক আছে? যদি আমি ক্যালকুলেট করতে বলি, সাপোজ if we calculate tau 12, কি হবে? 12 কে তুমি ফ্যাক্টরাইজেশন করো, ঠিক আছে? That means 12 is equal to 2a square into 3, ঠিক? So tau 12 পাওয়ার কি আছে? 2 এর সঙ্গে জাস্ট পাওয়ারের সঙ্গে 1 অ্যাড, ঠিক আছে? 3 এর পাওয়ার কি আছে? 1 এর সঙ্গে 1 অ্যাড, that is 2 plus 1, 3 into 2, that is 6. That is we have total 6 positive divisors of 12. You can check this. 12 1 2 12 কে ডিভাইড করে, 3 12 কে ডিভাইড করে, ঠিক 4 12 কে ডিভাইড করছে, 5 হবে না, 6 12 কে ডিভাইড করে, 12 12 কে ডিভাইড করে। সো 1 2 3 4 5 6, how 12 is 6, ঠিক আছে। সো দিস ইজ দ্য প্রসেস টু ক্যালকুলেট টাউ ফাংশন, ঠিক আছে। ওকে, সো নেক্সট, so it is a very important result. If G is a cyclic group of order n, then the number of subgroups will be tau n. Okay, so next, let G be a cyclic group of order 6. What is given? Order of G cyclic group is 6. Then the number of elements G belongs to G such that G is generated by this element, that is G is a cyclic group. We know that the number of elements, that means we have to calculate number of generators, number of elements, that is we have to calculate number of generators. So number of generators, that is how to calculate number of generators, Euler's phi function, right? So basically we have to calculate phi 6. So phi 6, that is phi prime factor, so 3 into 2, m and n are relatively prime, right? Phi m, that is phi m into phi n, so phi 3 into phi 2, right? We already know this property, phi p, if p is prime number, then phi p is p minus 1, right? Phi p is p minus 1 when p is prime. So 3 is a prime number, so 3 minus 1, phi 2, p2 is a prime number, 2 minus 1, so 2 into 1, that is 2. So which option is correct? So option D is the correct answer. That is, number of elements in a cyclic group is equal to the number of generators of the group. Okay, it is a very important note. So next, which of the following statement is true? একটা property আছে, every finite cyclic group is isomorphic to Zn. Just see, Zn is a finite cyclic group. Zn is a finite cyclic group. What is an example of infinite cyclic group? The example of infinite cyclic group is Z. Z is an infinite cyclic group. Zn is a finite cyclic group, right? The finite cyclic group is always isomorphic to Zn, and infinite cyclic group is always isomorphic to Z. Finite cyclic group is always isomorphic to Zn, and infinite cyclic group is isomorphic to Z. So this is true. ठीक? Okay. Z slash 37Z. So this is basically isomorphic to Z37. So this is a, we know that Zn is a cyclic group, so this is a cyclic group. So this is also true. We know that every group, every cyclic group is abelian, but abelian group is not cyclic. Just note this, every cyclic group is abelian, that is cyclic implies abelian. Okay, but converse is not true, that is abelian group is not necessarily, abelian group is not necessarily a cyclic group. Cyclic হলে সেটা অবশ্যই abelian হবে, কিন্তু converse is not true, that is abelian is not necessarily implies cyclic. So here it is in every commutative, that is abelian group is cyclic. This is true, false, right? But conversely, but not conversely, দেখো এখানে কি বলছি, abelian group cyclic, abelian group is not cyclic, so this statement is false. Every cyclic group is abelian, but every abelian group is not cyclic. For example, Klein's 4 group is abelian, but it is not cyclic, it has no generator. Okay, next, every subgroup of a finite cyclic group, that is cyclic. Every subgroup of a cyclic group is cyclic, so this is true. So 1, 2 and 4 are true, so option D is the correct answer. Okay, so it is very important, every finite cyclic group that is isomorphic to Zn, and every infinite cyclic group that is isomorphic to Z. Also, it is very important result, every cyclic group is abelian. Also, it is also an very important result, every group of prime order is cyclic. It is also an important result, every group of prime order is cyclic. Every group of prime order every group of prime order is cyclic. What does it mean? Suppose G is a group of prime order. Suppose order of G is prime. Okay, suppose order of G is P, that is what P is prime. So this implies that G is cyclic. Okay, what is P? P is prime. So again, we know that every cyclic group is abelian, that is cyclic implies abelian. So what we can say? So we can say that every group of prime order is abelian. Just see, every group of prime order is cyclic. Again, we know that every cyclic group is abelian. That means every group of prime order is abelian. Okay. So next, the group Z2 cross Z2. Just see, Zm cross Zn is not isomorphic to Zm. Zm cross Zn, that is isomorphic to Zn if M and N are relatively prime, right? Just recall this, Zn cross Zm, this is isomorphic to Zmn if and only if M and N are relatively prime. Okay, so basically it is very important. Z2 cross, দেখো আমি বলেছিলাম just first the example আমি ডিসকাস করেছিলাম, যে see, this every group of order 4, দেখো 4 অর্ডারের গ্রুপগুলো কি কি হতে পারে? ক্লেন্স 4 গ্রুপ, order of this group is 4, Z4, Z2 cross Z2, ঠিক, Z2 cross Z2, this is not cyclic. Why this is not cyclic? We know that Zm cross Zn, so this is cyclic if and only if M and N are relatively prime. Just recall this, Zm cross Zn, so this is cyclic if and only if M and N are relatively prime. So this is not relatively prime, so this is not cyclic. Okay, ঠিক আছে, apply this concept. Z2 cross Z2, can you say this is cyclic? No, because Zm cross Zn, so this is cyclic if and only if GCD of M and N is 1. Zm cross Zn, this is cyclic if and only if M and N are relatively prime. Okay, so Z2 cross Z2 is not cyclic. Okay, basically Z2 cross Z2, this is isomorphic to Kleins 4 group. This is not cyclic, this is also not cyclic. Z2 cross Z2, so this is isomorphic to Kleins 4 group. Okay, this is not isomorphic to Z4. Okay, because Zm cross Zn, this is isomorphic to Zmn if M and N are relatively prime. So option B is the correct answer. ঠিক আছে? Okay, so next problem, similar, just see Z3 cross Z3, this is not cyclic, right? Z3 cross Z3, this is not isomorphic to Z9, because we know that Zm cross Zn, so this is isomorphic to Zmn if and only if GCD of M and N is 1. If M and N are relatively prime, then we say that Zm cross Zn is isomorphic to Zmn. So the Z3 cross Z3 cross Z3, these are not relatively prime, so this is not isomorphic to Z9. So option C is the correct answer. ठीक? Okay, so next example, we know that R comma plus, Q comma plus, that are not cyclic group, right? Z comma plus is a cyclic group, so Q comma plus, this is not cyclic, this is not finitely generated, but all subgroups of Q comma plus, that is cyclic. So option C is the correct answer. It is very important. Q comma plus, that is not finitely generated, it is not cyclic, but its subgroups, but every finitely generated subgroups of Q comma plus, that is cyclic. So option neither it is cyclic nor finitely generated. So option C is the correct answer. Q comma plus, this is not cyclic group. Q comma plus, that is not finitely generated. Okay, but every finitely generated subgroup of Q comma plus, that is cyclic. It's a very important property. Okay, so next, it's a theorem basically. Let G be a group and G, if G slash ZG is cyclic, that is basically this is a quotient group. G slash ZG is cyclic implies that G is cyclic. This is theorem. Okay, G slash ZG is cyclic implies that G is cyclic. So option A is the correct answer. রেজাল্ট গুলো খুব ভালো করে কিন্তু একদম পুরো প্র্যাকটিস রাখতে হবে, না কিন্তু পাবে না। ওকে, সো নেক্সট দেখো, what is given here, 1 alpha alpha square alpha to the power 11 are 12 roots of unity. বেসিক্যালি ইকুয়েশনটা কি হবে এখানে, বেসিক্যালি এরকম একটা ইকুয়েশন দেওয়া আছে, x to the power n, x to the power 12, x to the power 12 minus 1 is equal to 0. এর রুটস গুলো 1 আলফা আলফা স্কয়ার আলফা টু দি পাওয়ার 11 লাইক দিস, ঠিক? ওকে, 12 roots of unity forming a cyclic group, because we know that this set of all nth roots of unity forms a cyclic group with respect to multiplication, right? This cyclic group under multiplication, then alpha to the power 9 generated by a cyclic subgroup of the above containing 12 elements, 8 elements, 9 elements, 4 elements. Alpha to the power 9, alpha to the power 9, this generates a cyclic subgroup of the above, that is this element containing কতগুলো element, 12 elements, 8 elements, 9 elements, 4 elements. That means basically we have to calculate order of this element. Basically we have to calculate order of this. Okay, we have to calculate order of this. Alpha to the power 9, this generates a cyclic subgroup of the above containing this element. So basically we have to calculate order of this. That means order of alpha to the power 9 এটা আমাকে ক্যালকুলেট করতে হবে, ঠিক আছে? ওকে, ঠিক, দেখো এখানে ফার্স্ট আমি এটাকে আমি একটু অপশনগুলো নিয়ে চেক করো। দেখো এখানে তো তোমার, আমি যদি এরকম কনসিডার করি আলফা টু দি পাওয়ার আলফা, দিস x to the power 12 minus 1 is equal to 0. That means alpha 12 roots of unity, right? These are forms the 12 roots of unity. তার মানে এখানে আমি কি বলতে পারি যে আলফা টু দি পাওয়ার 12 দ্যাট ইজ 1, ঠিক? এই কন্ডিশনকে অ্যাপ্লাই করতে হবে, ঠিক? Order of this will be 12 because this set contains 12 elements, right? So order of, দেখো এটাকে আমি যদি আলফা টু দি পাওয়ার 9 টু দি পাওয়ার যদি আমি আগে দেখো ক্যালকুলেশনটা করো, আমি যদি এটাকে আমি এরকম নিচ্ছি, ফার্স্ট মনে করো আমি সবগুলো নিয়ে চেক করছি, 4 নিলাম, মানে আলফা টু দি পাওয়ার কি হবে 36, দ্যাট মিনস আলফা 12 কিউব, alpha to the power 12 is 1, 1 cube, that is 1, ঠিক? That means order of this element will be 4. এবার তুমি ধরো এটা ক্যালকুলেশন করো, 9 elements কি হবে, that means can you calculate this alpha to the power 99 to the power 9, that is alpha to the power 81, alpha to the power 81 কে এটাকে এক্সপ্রেস করতে পারবে? এটাকে তুমি কি লিখতে পারবে? দেখো এই ফর্মে কনভার্ট করা যাচ্ছে না, আমাকে এই রেজাল্টটা ইউজ করতে হবে, alpha to the power 12 is 1, ঠিক? ওকে, ক্লিয়ার? দেখো এটা তুমি কি লিখতে পারো, আলফা টু দি পাওয়ার 12 যদি 6 করি, দ্যাট ইজ আলফা টু দি পাওয়ার, এটা কি পাবো, আলফা টু দি পাওয়ার 72 ইন্টু আলফা টু দি পাওয়ার 10 হয়ে যাবে, তাই তো? আলফা টু দি পাওয়ার 72 ইন্টু আলফা টু দি পাওয়ার 10, দ্যাট মিনস সরি আলফা টু দি পাওয়ার 8, কি হবে এখানে 9, alpha to the power 72, that is 1 into alpha to the power, that is alpha to the power 9 পাচ্ছি। তাহলে অর্ডার অফ alpha to the power 9 কে আমার অর্ডারের ডেফিনিশন কি, a to the power n is equal to কি হতে হবে আইডেন্টিটি এলিমেন্ট হোয়াট ইজ দ্য আইডেন্টিটি এলিমেন্ট 1 is the identity element সো আমি কিন্তু অর্ডার অফ আলফা টু দি পাওয়ার 9 আমি ক্যালকুলেট করতে পারছি না ঠিক আছে বোঝা গেল স্যার সিমিলারলি তুমি এগুলো ক্যালকুলেট করবে আলফা টু দি পাওয়ার 9 টু দি পাওয়ার 8 দেখবে তুমি 1 পাবে না ঠিক আছে ওকে সো অর্ডার so alpha to the power 9 is 4 that is order of this element so this will be 4 that means alpha to the power 9 generates a cyclic subgroup containing this element containing 4 elements okay ঠিক আছে so next problem which of the following statement is true every cyclic group is abelian right cyclic implies abelian so this is true every cyclic group is abelian so this is true every abelian group is cyclic every cyclic group is abelian but converse is not true that is abelian group is not necessarily a cyclic group so this is false there is at least one abelian group of every finite group of order n that is true it is obvious there is at least one abelian group of finite order কোন একটা গ্রুপ যদি finite group হয় তাহলে at least one abelian group exist for example identity element okay every group of order less than 4 is cyclic কেন হচ্ছে এটা কি ট্রু দেখো কিছু যদি প্রপার্টি অ্যাপ্লাই করতে হবে আমরা যদি সাপোজ অর্ডার অফ g is 2 this is the prime number we know that every group of prime order is cyclic so g is every group of prime order is cyclic every group of prime order is cyclic right that is order of g is prime implies that g is cyclic again cyclic implies abelian so every group of order 2 is abelian or we can say cyclic implies abelian next suppose order of g is 3 which is a prime number every group of prime order is cyclic that is g is cyclic okay next suppose order of g is 4 that means 2 square p square ফর্মে পাচ্ছি that means g is abelian but not cyclic g is abelian এখানে অপশনটা কি বলেছে every group of order less than 4 is cyclic obviously দেখো less than 4 if every group order if suppose g is a group of order 2 this is cyclic if g is a group of order 3 this is cyclic so every group of order less than 4 is cyclic it should be noted that up to order 5 every group is abelian note this point up to order 5 note this point up to order 5 up to order 5 every group up to order 5 every group is abelian কেন স্যার why দেখো 2 3 already this is cyclic order of g is 2 cyclic implies this is abelian cyclic this is abelian it is already abelian ঠিক 4 order abelian 5 order যদি 5 হয় 5 is a prime number so every group of prime order is cyclic again cyclic is abelian so if order of g is 5 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 then g is abelian g is cyclic right again cyclic implies abelian right so we conclude that up to order 5 every group is abelian it is very important up to order 5 every group is abelian but not cyclic দেখো order 4 order এ যদি কোনো এলিমেন্ট থাকে কোনো গ্রুপ হয় তাহলে কিন্তু সেটা সাইক্লিক হচ্ছে না abelian হচ্ছে so up to order 5 every group is abelian and up to order 3 every group is cyclic okay so which option this is true option so 1 3 and 4 so these are true 1 3 and 4 ঠিক আছে clear so next problem it is a result okay A and A square are both generators of a cyclic group of order n, then n must be odd, n must be even, n must be prime, n must not be a prime. Just see, it is a very, very important result. A to the power r is a generator of the cyclic group of order n if r is less than n and prime to n. A to the power r, this will be a generator of the cyclic group G of order n if r is less than n and prime to n. Okay, a to the power r G এর generator হবে যদি r টা n এর থেকে if r is less than n and it will be prime to n. So A and A square both are generators of the cyclic group of order n. দেখো A square ধরো suppose A square, তাহলে A square যদি generator হতে হয় G, suppose G is a cyclic group of order n, তাহলে 2rn কি হতে হবে, প্রাইম হতে হবে, ঠিক? 2rn কি হতে হবে, প্রাইম। দেখো এই রেজাল্ট অ্যাপ্লাই করো, a to the power r a square, so this will be a generator of the cyclic group G of order n if r is less than n and prime to n, ঠিক? তাহলে এখানে যদি আমি নাম্বারটা, তাহলে যদি n কে আমি 2 কনসিডার করি সাপোজ, তাহলে এটা তো এর সঙ্গে প্রাইম হচ্ছে না, হচ্ছে কি হচ্ছে না, তার মানে এনটাই কি হতে হবে, এখানে অড হতে হবে, n মাস্ট বি অড। ফর দিস এক্সাম্পল n মাস্ট বি অড। দেখো অড নাম্বার যদি কনসিডার করো, তাহলে এস ধরো আমি ফর এক্সাম্পল এ স্কোয়ার, তো এ স্কোয়ার দ্যাট ইজ এ জেনারেটর অফ দিস সাইক্লিক গ্রুপ, সাপোজ n is equal to 3, 2 and 3 are relatively prime, 2 is less than 3. Okay, so n must be odd. So which option is correct? So option A is the correct answer. It is very important note, a to the power r, so this will be a generator of the cyclic group G of order n if r is less than n and prime to n. A to the power r, so this will be a generator of a cyclic group G if r is less than n and prime to n. Okay, so option A is the correct answer. Next, un, basically we denote un with a set of all positive integers less than n and prime to n. ব্যাপারটা কি Euler's phi function, right? Just recall the Euler's phi function. Euler's phi function, that is the number of positive integers less than n and prime to n. What is Euler's phi function? The number of positive integers less than n and prime to n, that is Euler's phi function. Phi n is defined such a way that phi 1 is 1 and phi n, that is number of positive integers less than n and prime to n. So basically here un, that is phi n, just you consider this is phi n with a set of all positive integers less than n and prime to n. So here we have to calculate, basically we have to calculate the number of elements in un, that is what is n is 248, so basically we have to calculate phi 248, just 248 কে আমি ফ্যাক্টরাইজেশন করব, so this will be 2 cube into 31. m and n are relatively prime, so this will be phi 2 cube into phi 31, right? We know this result, phi p to the power k, where p is prime, so this will be p to the power k minus p to the power k minus 1, so that is 2 cube minus 2 square. This is the prime number. We know this property, if p is prime number then phi p will be p minus 1, ठीक? Phi p will be p minus 1, right? Okay, so this will be 30 minus, right? So 2 cube, that is 8 minus 4, that is 4 into 30, so this will be 120. So option D is the correct answer, ঠিক আছে? So basically here we have to calculate phi 248. Okay, last example of today's class. If G is a finite group of order n, that is order of G is n, okay, which of the following statements must be true? Option A, G is cyclic for all values of n. This is obviously, this is false. G is cyclic for all values of n. Obviously this is false. Why? For example, দেখো অপশন এ এর জন্য আমি যদি ক্লেন্স ফোর গ্রুপ কনসিডার করি, ইফ ইউ কনসিডার the Kleins 4 group, what is the order of Kleins 4 group? The order of Kleins 4 group is 4, right? So this is abelian but not cyclic. This is not cyclic. So G is cyclic for all values of n. What is n? N is the order of the group. So this is false statement. Okay. Tick. So next, G is cyclic if and only if n is prime. That is also false. This is false. This is false. This is also false. Can you sir? Why? দেখো if and only বলা আছে, we know that every cyclic group is every group of prime order is cyclic. কোন গ্রুপের অর্ডার যদি প্রাইম হয় তাহলে সাইক্লিক, কিন্তু কনভার্সটা কিছু বলেছে every group of prime order is cyclic. That is, if a group G has prime order, then must be cyclic. But example এ ডিসকাস করি তাহলে বুঝতে সুবিধা হবে। ধরো if we consider this group, suppose Z4 for option B, if we consider the group Z4 is a cyclic group, right? Because we know that Zn is a cyclic group, right? Z4 is a cyclic group, right? Z4 is a cyclic group. Z4 is a cyclic group of order. What is the order of Z4? Of order 4. So this is an even, this is not prime, right? Z4 is cyclic of order 4, which is not prime. 4 is not prime. Clear? But 4 is not prime. Getting my point? So this is also false statement. G is cyclic if and only if n is prime. That is also false. This is an example. Z4 is a cyclic group. Z4 is a cyclic group, but 4 is not prime. If and only G is cyclic, but n must, G is cyclic implies n must be prime. Z4 is a cyclic group, but 4 is not prime. So this option is also false. Is it clear? Z4, this is a cyclic group. What is the order of this group? The order of this group is 4, but 4 is not prime. But here it is given, if G is cyclic, then n must be prime. G is cyclic implies n is prime, so which is false. If and only if G is cyclic implies that n is prime. But here we see Z4 is cyclic, but 4 is not prime. So option B is also false. Next, for option C. G is abelian if and only if n is even. We know that the symmetric group S3, that is non-abelian. The symmetric group, we just recall this Sn, the Sn where n is greater than equal to this, so this is non-abelian. So S3 is a non-abelian group, right? So for option C, if we consider the symmetric group S3, so what is the order of S3? We know that the order of the symmetric group Sn, so that is factorial n. So order of S3 is, that is factorial 3. Factorial 3 is 6. Factorial 3, that is 6. So this is an even number. But we know that this is not abelian group. But S3 is non-abelian. So what is given? G is abelian if and only if n is even. দেখো আমি n টা even পাচ্ছি, order of the group is even, but it is not abelian. Is it clear? We see that order of this group is even, but it is not abelian group. This is non-abelian group. It should be noted that the order of Sn is factorial n, and Sn, that is the symmetric group Sn, is a non-abelian group, and that is a finite group. Okay, that is a finite group. ভাইবাদের জিজ্ঞেস করে যে given example of a finite group which is not abelian. So S3, this symmetric group S3, this is finite group, but it is not abelian. Okay, so option C is also false. Option C is also false. ठीक? Option C, that is also false statement. Next, come to our last statement. It is given that G is abelian if and only if n is odd. G is abelian if and only if n is odd. Right? G is abelian. So for final option, that is option D, for option D, G is abelian, যেটা abelian হবে যদি n টা odd হয়, if and only if condition. আমি যদি if we consider the group Z3, Z3 is cyclic, obviously Zn is cyclic. Again, every cyclic group is abelian, that is Z3, that is abelian. Okay, and what is the order of Z3? And the order of Z3 is 3, ठीक? And has order, and order of Z3 is 3. ঠিক আছে, এটাও ক্লিয়ার? অর্ডার অড গ্রুপটা কি হচ্ছে, অ্যাবিলিয়ান হচ্ছে। ঠিক আছে, is it clear? Z3 is abelian and order of Z3 is 3. So we conclude that if if n is odd, then Z3 is abelian. Okay, এবার যদি আমি গ্রুপটা এটা কনসিডার করি, সাপোজ if we consider this group S3, S3 is non-abelian, right? S3 is non-abelian, and what is the order? And has order, what is the order of S3? That is 6. দেখো এখানে অর্ডারটা ইভেন, কিন্তু গ্রুপটা কি পাচ্ছি নন অ্যাবিলিয়ান, এখানে অর্ডারটা অড, গ্রুপটা কি পাচ্ছি অ্যাবিলিয়ান। এবার যদি এরকম একটা কনসিডার একটা সেট ধরো Z2 যদি কনসিডার করি, সাপোজ ইফ ইউ কনসিডার দিস group Z2 is cyclic because Zn is cyclic, so Z2 cyclic implies abelian, so Z2 is, we conclude that Z2 is abelian. But what is the order of Z2? And order of Z2, that is 2, so which is even? Yes or no? Just see, counter example নিয়ে consider করো। Z3, this is abelian, and what is the order of Z3? is 3. ঠিক? Okay, Z3 is abelian if order of Z3 is 3. ঠিক? Okay, S3 is non-abelian, has order 6. Okay, এখানে কি বলেছে অপশনটা, G is abelian if and only if n is odd. nটা যদি odd হয় তাহলে সেটা abelian হচ্ছে। সো অপশন, বেসিক্যালি অপশন দেখো, এটা ফলস, এটা ফলস, এটা ফলস, দ্যাট মিন্স অপশন, এভাবে বলতে পারো যে অপশন ডিটা হচ্ছে কারেক্ট অ্যান্সার। বোঝা গেল আমি কি বলতে? দেখো এখানে আমি যদি Z3 is abelian, what is the order of Z3? order of Z3 is 3. সো যদি অর্ডারটা যদি অড হয় তাহলে গ্রুপটা কি হচ্ছে, অ্যাবিলিয়ান হচ্ছে। ওকে, S3 is non-abelian, has order, তাহলে ইভেন হলে non-abelian, বাট অ্যাবিলিটি ঠিকই আছে। Z2 is abelian if order of Z2 is 2, that is even, তাহলে ইভেন হলে অ্যাবিলিয়ানও হচ্ছে। দেখো হ্যাঁ, ইভেন হলে একবার অ্যাবিলিয়ান, ইভেন হলে একবার নন অ্যাবিলিয়ান, সো অপশন সি ইজ ফলস। কিন্তু আমি যদি অর্ডারটা যদি অড কনসিডার করি তাহলে সেটা অবশ্যই কি হচ্ছে, অ্যাবিলিয়ান হচ্ছে। ঠিক আছে, সো অপশন ডি ইজ দ্য কারেক্ট অ্যান্সার, সো দিস ইজ ফলস। ওকে, দ্যাট ইজ ভেরি ইম্পর্টেন্ট, যে এক্সাম্পল ডিসকাস করলাম, ইট ইজ ভেরি ইম্পর্টেন্ট। জি সাইক্লিক ইফ অ্যান্ড অনলি ইফ এন ইজ প্রাইম, আমরা এভরি গ্রুপ অফ প্রাইম অর্ডার ইজ সাইক্লিক, এটা ডিরেক্টলি করে দাও তাহলে কিন্তু এক্সাম ভুল হয়ে যাবে। ঠিক আছে, দেখতে হবে। আমি দেখো এই এক্সাম্পলটা কি কনসিডার করলাম, Z4, দিস ইজ এ সাইক্লিক গ্রুপ বাট 4 ইজ নট প্রাইম। Okay, so option D will be the correct answer. ঠিক আছে, G is abelian if and only if n is odd. Okay, right? ঠিক আছে, ওকে। সো আজকে আমি টোটাল 25 প্রবলেম ডিসকাস করে দিলাম অন দি টপিক সাইকেল গ্রুপ। সো লেকচার ওয়ানে আমি 30 প্রবলেম ডিসকাস করেছিলাম লেকচার ম্যারাথন সিরিজের লেকচার ওয়ান, দ্যাট ইজ প্রপার্টিস অফ গ্রুপ, প্রপার্টিস অফ গ্রুপ অ্যান্ড দেয়ার প্রপার্টিস থেকে 30 প্রবলেম ডিসকাস করেছিলাম। অর্ডার অফ এ সাবগ্রুপ, অর্ডার অফ অ্যান এলিমেন্ট, অর্ডার অফ এ গ্রুপ থেকে 15 প্রবলেম ডিসকাস করেছিলাম। সাবগ্রুপ থেকে 20 প্রবলেম ডিসকাস করেছি, আর সাইকেল গ্রুপ থেকে 25 প্রবলেম ডিসকাস করে দিয়েছি। সো টোটাল 90 প্রবলেম আমি ডিসকাস করে দিলাম। এই প্রবলেমগুলো খুব ভালো করে সলভ করবে, ঠিক আছে? সো এই প্রবলেমগুলোই সলভ করো, তাহলে আই থিঙ্ক অ্যাটলিস্ট খুব বেসিক কনসেপ্ট ক্লিয়ার হয়ে যাবে এবং যে কোনো প্রবলেম সলভ করতে পারবে। ওকে, ক্লিয়ার? সো দিস 25 প্রবলেমস আর ভেরি ভেরি ইম্পর্টেন্ট। ওকে, সো সমস্ত রেজাল্টগুলো যে প্রপার্টিসগুলো আমি ডিসকাস করেছি সেই প্রপার্টিসগুলো খুব ভালো করে পয়েন্ট আউট করবে। সো দ্যাট আর দি মোস্ট ইম্পর্টেন্ট প্রপার্টিস, জাস্ট পয়েন্ট আউট দিস আর দি মোস্ট ইম্পর্টেন্ট প্রপার্টিস দ্যাট আই repeatedly use, that is this if G is a group, cyclic group of order n. Let's see, if G, the number of generators of a cyclic group G of order n is pi, and that is a very very important result. Okay, if G is a cyclic group of order n and a to the power k is a generator of G, if GCD of k and n is 1, that means k is relatively prime to n, that is k is less than n and prime to n. It is also important result. Okay, there exists a finite group whose proper subgroups is cyclic but the group is not cyclic, for example q comma plus, right? Next, this is very important, every group of prime order is cyclic but converse is not true. Okay, but converse is not true. It should be noted that suppose G is a finite group, finite cyclic group, it has an element which is the same as the order of the group itself. A finite group G is cyclic if it has an element which has the same order as the group itself. তার মানে কি, suppose G is a cyclic group which is generated by an element A, তার মানে G এর অর্ডার যা হবে সেই এলিমেন্টের অর্ডার সেম হবে। জাস্ট অ্যাপ্লাই, এই রেজাল্ট আমি কোথায় অ্যাপ্লাই করেছি? ফর দিস এক্সাম্পল, just see, let G be a cyclic group generated by an element A. What is the order of the cyclic group? Order of the cyclic group is 30, that is order of this element will be also 30. Okay, so this is also an important result that I used, right? Okay, so next one is, these are the basic knowledge. Claims-4 group is abelian but not cyclic. Okay, this is very important, every cyclic group is abelian but converse is not true. Okay, next one is this, the number of subgroups of a cyclic group of order n is tau n. What is tau n? That is number of positive divisors. The number of subgroups of Zn, that is tau n. Why? That these two are similar. Zn is a cyclic group, right? Zn is a cyclic group, so the number of subgroups of a cyclic group of order n is tau n. Zn is a cyclic group. What is the order of Zn? Order of Zn is tau n. So the number of subgroups of Zn will be tau n. What is tau n? Tau n is the positive divisors of n. Okay, this is important. The every group of order 4 is isomorphic to either 4 or Z2 cross Z2, Z2 cross Z2. Basically this is isomorphic to planes 4 group. Okay, bas. So আমি যে important result গুলো আমি this is very important, any group of order p square or p is prime that is abelian, so that are repeatedly used. Okay, so these are the very important properties. এই properties ও বেস করে আমি ম্যাক্সিমাম প্রবলেম গুলো সলভ করেছি। ওকে, ঠিক আছে, so I think clear. Okay, so these 25 problems are very very important. So I request to all of you, please do all problems very carefully. Okay, so thank you so much. Bye.